Good morning all. I am Praveena, working as Assistant Professor in Department of Information Technology, BVRIT Narsapur. Today I am going to explain about data structure topics. Now let us discuss about the definition of data structure. Data structure is a way of organizing the data and accessing the data in the computer, which can be accessed anywhere in the program in the data structure. So now let us see what is ADT. ADT is nothing but abstract data structure. Abstract data structure is nothing but showing the essential details without showing the internal details. That means here we are having a set of data values and we will show only the operations that are performed on the set of the data values without showing the implementation of these implementations of the operations on data sets. Now let us discuss what are the different types of abstract data types. So we have different types of abstract data types. Here we are having built-in data structures and user-defined data structures. In built-in data structures, we are having arrays, stacks, queues, and in undefined data structures, we are having trees, binary trees, breadth-first search, so many things we are having. So the first one in the built-in structures is integer, float, char, pointer. And user-defined data structures is arrays, list, files, linear list, non-linear list, stacks, queues, trees, graphs. And now let us discuss what is list ADT. So list ADT is nothing but here we are discussing about the linked list. Linked list consists of two fields. That it means first of all the list contains two fields. One is the node and the another one is data. So in the data we are having the first field as data and the next field we are having the pointer to the next node. So here list means it contains the collection of nodes. So the node, it contains the first field as data and the second field it contains the pointer to the next node. That means the node contains two fields. The first field it is called data field. The second field it is called as the pointer, is nothing but address of the next node. So the second field it contains the address of the next node in the list. So list is nothing but it is a collection of nodes and each node contains two fields. One field is, the first field is called as data field and the second field is called as the pointer to the next node. So pointer to the next node is nothing but it contains the address of the node that is present to next of this node. So here it is the collection of nodes is nothing but linked list and the last node it points to null pointer. So now let us discuss in detail about each and every point of list ADT here. So let us see the first point. So what is the first point we are having here is list ADT is basically the collection of elements arranged in a sequential manner. So already I told you each and every element is arranged in a sequential manner, one after the other. So sequential means in the order here we are having. So this is one node which contains two fields and this is another node which contains two fields and this is another node which contains two fields. So here and these nodes are interconnected to each other like this. And I already told you each node contains two fields. The first field is data field and the next field is pointer, means the address of this node is present in the previous node. and the address of the next node is present in the previous node. So on the last node, how can we know this is the last node? Means this is pointing to null pointer. That means there are no any other nodes in the list next to this node. So this is the representation of list ADT. So list is nothing but here we are having list of elements which are interconnected to each other, and the list contains the nodes, and each node contains two fields. One field is data field and another field is pointer field. So next point here is we are having in memory we can store the list in two ways. Let us see what are those two ways. One way is we can store the elements in sequential memory locations. That means side by side memory locations. Instead of representing in the form of tree, hash, something else. So here we are representing data in the linear manner. That is, the elements are arranged in a sequential manner. Now let us see next point. That means we can store the list in the form of arrays. So everyone is familiar what is array. Array is a collection of homogeneous data items. That means the data in the same data type, either in float, collection of float data types, either a collection of integer data types, either the collection of double integer types, whatever it may be, the data item should be of same data type. It should not be different types. So this is already known. Array means we are already familiar. Now let us discuss what is list. What is the difference between the list and the array? So already I said you, array means collection of homogeneous data item. But here what is the difference between the array and the list? Means array, it is static. That means the memory is static in the case of array. Whereas in the case of list, the memory is dynamically allocated. What is the difference between static and dynamic? Means, so once the array is created, that means before creating the array, the memory size of the array has to be declared. Suppose if I declare the size of the array as 10, then the elements that are stored in the array is restricted to the 10 values. That means whatever the memory that is allocated for the array, so that elements can only be stored in the array. But whereas coming to the linked list, so in the linked list it is dynamic. Why we are saying dynamic? Means here the elements can be added or removed whenever we need it. According to our necessity, the elements can be added. That means the list can be increased according to our necessity, and the list can be deleted. That means the nodes that are present in the list are deleted according to the requirement. That means without wasting the memory. So the nodes can be deleted from the list in order to avoid the wastage of memory in the list. And whenever we want to insert the element, wherever, at whichever position we require, either at the front of the list, at the end of the list, at the middle of the list, wherever we require to insert the element or delete the element, or we can traverse the elements in the list. But that is not possible with the array. So once the elements are added to the array, the elements cannot be neither deleted nor added in the middle. So the array is static, whereas the linked list or the list is dynamic. We are saying the difference. So list is dynamic. We can grow the memory, we can shrink the memory whenever it is not needed. Now let us go to next one. Linked list is very different type of collection from an array, which I already told you. Using such lists, we can store collection of information limited only by the total amount of memory that the OS will allow us to use. Already this point I have discussed. So in array, we can store only the elements. That means already we have declared the array size as suppose 8. So the size of the array 8 has been declared. So only 8 elements can be given for the array. That means suppose I will give the array size as some 20 bytes. So in the 20 bytes, suppose integer takes some, each element takes 4 bytes. So here 4 into 5. So only 5 elements can be stored in the array in the case of array. But whereas furthermore, there is no need to specify our needs in advance. So in the case of array, no need to specify. And in the linked list, it is flexible dynamic data structure. So this one, flexible dynamic means whenever we want, we can add the elements in the linked list, and whenever we want to delete the elements from the linked list, we can delete the elements. So a programmer need not worry about how many items a program will have to accommodate in advance. Where in the case of array, in advance we have to mention the number of elements that should be stored in the array. But in the case of linked list, we are least bothered about the number of elements that are to be stored in the linked list. Why? Because whenever we want, we can add the elements in the list, and whenever we want, we can delete the elements from the list. So this allows to write robust programs which require much less maintenance. What is the meaning of robust? Means the program failure will be less. So what are the disadvantages of linked list? There is no direct access to a particular element. Why? Because always we have to access the element with the help of the pointers here, and additional memory required for pointers. So in the case of array, there are no pointers, but here in the case of single linked list or linked list, here we need pointers which store the address of the next node or next element. So here additional memory for the pointers will be wasted. So we discussed today what is the definition of the data structure, where the data is organized and stored in a computer so that whenever the user want to access the data, that can be accessed. And we have discussed ADT, abstract data structure, which shows only the essentials without showing the internal details. And we have discussed the list ADT. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.